right, so this week we are going to be talking about creating classes and inheritance and a couple of related things. The book is going to go into great detail about all of this, but I wanted to give a high level overview how classes work, how to create them, why they're useful. So, first of all, if you've been creating the assignments in the way that the instructions indicated in the beginning of the course, then you'll notice that every assignment has a class already. When you create the solution, it'll ask you for the name of the class, or it'll create one by default for you. And this can be whatever you want, as long as it has a method, a public static void method named main with a capital N. All C# programs have to have one class with a main method, and that is where everything starts. So we've been doing that the whole time, so hopefully that's not too shocking for you. Now, a class is a blueprint for an object. It allows us to create a bunch of objects that have the same capabilities but different data. So let's look at an example of that. First of all, when we create a class, we are going to want to create it within the same namespace as the rest of our program most of the time. So there are a couple of ways we can do that. One way, we can actually create another file that sits in the same solution as long as it has the same namespace. The other thing we can do is just within the same file, we can create another class just right up here inside of the same namespace curly braces. That's what I'm going to do just so everything shows up on one page. In real life, most of the time, this is not what you do. Most of the time, you'll create a separate file that has the class in it, and then each file is its own class. But it doesn't really matter, and so just to make the illustration easier, I'm going to put it all in our main file. The key thing to make sure of is that you are creating it inside the same namespace, but separate from the existing class. So I'm going to create a class. All class definitions start with the word class. They have some accessibility qualifiers, just like everything else, internal, public, private, etc. But since we're in the same namespace, I don't need to do that. So I'm going to call this class person. This is going to be my person class. And like everything else we create, we are going to use curly braces to indicate where the item, where our class definition begins and ends. So a class can basically have two things, properties and methods. So a method is a function that's attached to a class, and properties are data that are attached to the class. So let's say that I want this person to have a name. Now, the book goes into a lot of detail about getters and setters and things like that. So I'm just going to give a high level overview of this, show you the old way to do it and the more modern way to do it. The person class, I want my person to have a name. And so I'm going to create a variable called name. I have to define the type. This is a variable declaration. But usually when we create a private variable, something that's only accessible within the class, we'll also prefix it with the word private, and then we will give the variable a special name. Sometimes people will prefix it with the letter M for member variable. Sometimes people will prefix it with an underscore. It doesn't matter as long as you're consistent. So this is going to be the name variable. Now, this is only accessible by functions within the class. So if I want to access this in other parts of my code, I have to have a public getter to be able to get that variable. And so the way I define that is I'll say I have a public string, and usually the property is uppercased. Create some curly braces here. And then I define what's going to happen when I get that property. So the getter is basically a special method that's going to return something. It's going to return a string that represents the name. Now I'm storing the string in this private variable, so I'm just going to return name. If I want to be able to change the name, I also have to define a setter, much the same way. But what I'll do in this case is I'm going to change the value of the variable. So I'm going to set name equal to whatever it is the person using the class sets it to. And that is stored in a special variable called value that's only accessible within the setter. So just to review, what's going to happen here is if someone tries to access the name property, it's going to pull the data from this internal variable that we can't access directly. If we try to change the name property, it's going to set that internal variable to whatever value we pass in. Okay. Now, if I leave the set out, if I don't include this definition, then this property is called read only. We can only get the information, we can't modify it. So what we're going to do now is create what's called an instance of the class, sometimes referred to as an object. So I'm going to create an object. So when I create an instance, I first declare the type, just like any other variable. Then indicate the variable name. In this case, we'll say X. And then I'll say this is going to be equal to a new person. So I have to declare the type, the name, and then create a new instance of that class. So it uses this definition as the blueprint to create a new person, which is stored in the variable X. So now I can say X.name is equal to Bob. And then I can say the name of the person is, we'll make this a format string, our $sign, X.name. So let's look at what's happening here. I'm going to instantiate a new instance of the class, which will be stored in this variable. So X is now a variable containing a class instance. We refer to that as an object. I then set the name property of the object stored in this variable to Bob. I then print out this line of text and include the value currently stored in that property by calling the name property here, or accessing the getter. So here I'm accessing the setter code. Here I'm accessing the getter code. Let's run that and see what that looks like. You'll see the name of the person is Bob. Okay, we're going to set a breakpoint here so we can see what happens. Now, one thing to note is that if I want to see what happens inside the property, there's a setting that I have to change. If I go under here, under the options menu, step over, I have to turn this off. Normally, the debugger just skips over property operations. I'm going to turn that off temporarily so we can step into that and see what happens. So I'm going to create a new instance of this object. And here I'm going to click the step into. And you'll see that I'm now calling the set method of this. This is the setter. And so I'm going to take this name variable, which currently is set to nothing, and I'm going to set it equal to value, which is what I've passed in to that setter. You can see the value is set to Bob. Now we're back in the main method. And when we get into the write line method, we are now calling the getter. So we come back up here. Our execution says return whatever's currently stored in name, and that's Bob. And that's what prints out. Now it's important to note that, again, this is the blueprint or a definition of what the person class looks like. I can create as many different versions of this as I want, just like I can create a bunch of different strings or a bunch of different ints or a bunch of different floats. So for example, I can create another person. Let's actually do it right up here. I can say person Y is going to be a new person. And I'm going to set Y's name to Tom. And then we'll just indicate here the name of the X person is X.name. And the name of the Y person is Y.name. So when I run this, notice that these variables, X and Y, they are separate objects. They're sitting in different places in memory. When I change X, it does not affect Y. And when I change Y, it does not affect X. They are both instances of the person class. They have identical properties, identical functions, but the data stored within the classes is different. Now, I told you there was going to be the old way and the new way of declaring this. Most of the time, almost every property we create for a class will look like this. We have a private variable attached to it. We have a public property defined with the same type. And then we have a getter that returns that variable and a setter that changes the variable to the value that's passed in. This is such a common pattern that there's a really handy shortcut to do all of this. So instead of writing all of that, you can just write, I'll put it up here so you can see the difference. Public string name get set. That's it. So this line is the same essentially as these lines. There are a couple other things that happen behind the scenes that are different, but if you just write this, it's the exact same thing as writing out all of this. And so we can see that if I delete all that code, we'll rerun this and see that the code works exactly the same way. So this is called property shorthand syntax. You are saying you can get this property, you can set this property, and the compiler knows by default how that should work. You can also define a custom getter or a custom setter or both using the methods that we created earlier, but most of the time you'll see that it looks like this. All right, let's do something a little more complicated with our person class. We're going to introduce what's called a class constructor. So a constructor is a method that automatically runs when the class is instantiated. The syntax for constructor is the word public and the name of the class with parentheses, and then everything else is just like a normal method. So for now, let's just do this. Let's just put a little thing in here that says, you have created a new person instance. So the constructor method automatically runs when we create a new instance of that class. So if I run this code, you can see that we get two printouts here because we are creating two different instances. If we were to step into this code and we step into that, we'll see that when we instantiate the new person, we go into the constructor, execute all of the code inside those curly braces, just like any other function. We go back to main, then we're creating a new instance and we're executing the constructor code, etc. Typically, a constructor is used to set default values for internal properties, or to allow you to pass information into the class when you create it, to use that information to set some defaults. Let's use that instance. So I'm going to move our property definition up here, and we will give our constructor a parameter. Let's call it name. Rid of this, and we'll say that this, so whenever we're referring to something internal to the class, we can prefix it with this so we don't get confused. This dot name is equal to the name that is passed in to this parameter. So now you'll see down here in this code that this little red squiggle says something's wrong, and that's because we have said that whenever we create a person, we need to supply the name. So when I create this person, we're going to call them Bob, and this person, we're going to call them Tom. Since we're doing that, we no longer need to use this. And when we run the code, you'll see that everything works as we expect. The name of X is Bob, the name of the Y person is Tom. So we're passing this value into the constructor. It gets stored here. The constructor runs. We take that value, store it inside of this property, which we can then access later on, as long as this class instance is still available within our scope. Now, just like any other function, we can have as many parameters as we want with different types. So let's do this slightly differently. Let's create two private variables here. And I'm going to call this first name and last name. And I'm going to change my person so that he takes two parameters, first name and another string for last name. And inside my constructor, I'm going to take those values and store them in these internal variables. This dot first name will be equal to the first name that we pass in, and this dot last name is equal to the last name we pass in. Now, it's just a coincidence that these are the same name, though it's a common pattern that you'll see. Also, the fact that I'm prefixing this with an underscore, not essential, but a good way to differentiate the parameter from the internal variable. Now, our name property, we're going to modify a little bit. I'm going to get rid of our shorthand syntax, and I'm going to change it so that when we get the name, I'm going to change it so that it returns this dot first name plus space plus the last name. Now, using this is optional. It will default to assuming that we are talking about variables within the class. but it's a good practice to get into so that you are explicit in your code. So now, again, we have these red squiggles here saying something's wrong because we've changed our constructor definition to say we need 2 strings. So I'm going to add a last name for Bob, and I'm going to add a last name for Tom. So now when I print x.name or y.name, it's going to call name, it's going to call the getter, and the getter, instead of just returning a single value, it's going to take some internal data and create a new value. We call this sometimes a derived property. This property is derived from these 2 internal variables. So when I run this, you'll see that now we get Bob Smith and Tom Jones. Everything works exactly the way it did before. The differences are we're passing in 2 values, and our name property isn't attached to a variable. It is instead a derived property that is creating something new. Also notice that in this setup, I've removed the setter. So if I try to say something like x.name equals whatever, it's going to give me an error that says that I cannot access this, cannot be assigned to, it is read only. And that's because I did not put a setter in. And I don't want a setter here because my name property is derived from 2 different strings. So I can't just set it to a single string and have it still work. So that's another common pattern you'll see. All right, I'm going to add another property here. I'm going to use the property shorthand syntax. This one's going to be an integer. It's going to be age, and we'll make it read and write. So we'll put a getter and a setter there. And in my constructor, I'm going to set the default. Whenever I create a new person, I'm going to set their age to 0. Now, I put that there because I want to create a new function. I'm going to create a public function that doesn't return anything. I'm going to call it say hello. And what this function is going to do is going to print out a greeting for this person. And we'll say right line, we'll use a format string. Hello, my name is this dot name. I am this dot age years old. So this is the say hello function. It's going to print out this string. So now, instead of doing this, I'll say x dot say hello. Now notice the format here. My method, my function, technically a method since it's attached to a class, is camel case, starts with a lowercase letter. Not required by the compiler, but a general practice you should follow. I'm going to run this and we'll see the greetings for both of our people. Now, I want to change the age of my X person to be 25 years old. So when I run that, now Bob is 25 and Tom is still 0 because that's the default. Okay, so again, just to retrace what's happening here, we create a new instance of this person. We pass in these 2 values for the parameters. Those get stored in first name and last name. Inside the constructor, we set age equal to 0 by default. Then here on this line, we're setting this instance's age to 25. So that uses this property to store that data. We then call the say hello method on both objects. The say hello method executes this code, which prints the object's name and the object's age.